But I'm Dani. I'm a second-year student currently in the BMC program, and I'm going to talk to you guys today a little bit about the work I did for Jody Jenkinson over the summer. I mostly did a lot of data analysis, which sounds boring, but if you're me, it's super fun. So primarily, I worked with data from a study examining the use of color in molecular animation. It was a study that had been previously conducted by Jody and I think Stuart back in 2014. And it was part of a larger project examining visual complexity and animation for learning about molecular events. So if anyone here isn't familiar with Jody's research, just kind of a brief overview is that a common misconception in undergraduate biology, as Andrea also kind of addressed, is the random nature or emergent nature of molecular interactions. Students tend to seek causality, so they tend to assume that everything is happening with purpose. And we need to, so we need to find a way to remediate that misconception. So before I dive too much into research here, I'm actually going to talk a little bit about color, because the focus of this talk is on how we use color as an attention cue. So how do we use color? Or more specifically, how do we use color to guide attention? So I imagine the answer to this question is pretty obvious to all of you as medical illustrators. But I'm going to take a moment to walk through it anyways. So here we've got a lot of spheres. But if there was a specific one of these spheres or a specific group of spheres I wanted you to pay attention to, you wouldn't know it looking at this, right? So that's where color is a powerful tool. Here, when we use color, we can draw attention to a specific element, or we can create a perceptual grouping of elements. So you associate the green balls as all being the same and the red as all the same and so on and so forth. So stating the obvious, in static illustration, color cues are powerful tools for drawing the eye. But why does this work? And so without going in too deep here, because again, this is probably something most of you are vaguely familiar with or very familiar with at this point, this is because of how our visual processing system works. So most of the information we perceive, so form, texture, environment, actually comes from a sort of luminance channel. So we're seeing things based on its value rather than its hue or its chrominance. Chrominance alone doesn't tell us very much. So color in and of itself is kind of not that great if we're wanting to perceive form and structure. But what color does exceed at is coding information into categories. Color allows us to create visual attributes for entities. And when an entity has chrominance information, we begin to use adjectives to describe it. So instead of just saying the sphere, you would then say, oh, the red sphere. This perception is what allows color to work efficiently as a means of coding information. Saturated, vivid colors are often processed pre-attentively, so we notice them before we begin consciously processing information. We subconsciously notice them because they tend to have that high contrast from their environment. So think of like red berries in a green bush. The color makes them more perceptually noticeable. It's because of this that color is a powerful attention cue, and when we deliberately apply it, we can use it to easily align perceptual salience and thematic relevance in a static illustration. So this begs the question, can we leverage the perceptual salience of color cues to support students' understanding of molecular processes as being emergent or random in nature? So to answer this question, back in 2014, Jody, Stuart, and Gail's name's on the conference paper, so yeah, Gail ran a study examining to what extent perceptually salient features, so color coding, contributes to supporting students' understanding of molecular processes as causal or collective. To do this, they created 3 treatments of the same animation depicting a receptor-ligand binding event. One uses selective color, so the first one you see there where the receptors are red, the ligand is green, right? Yes, and the membrane is yellow. The second one is a color transition. So the animation starts in full color, and then at a point partway through, the color kind of recedes, except for on selective features, so the receptors, ligand, and membrane, like in the first treatment. And then the third and final treatment is full color, so just everything is in color. It still has a degree of color coding, so each protein type would be the same color, so like the receptors are all red, the ligands are all green, blah, blah, blah. Yes. So, this is my beautiful graphic. 61 participants were recruited from undergraduate biology at UTM. These participants were then divided into 3 groups. Yes, so 1 group for each color treatment. Participants were then asked to watch the stimuli, and as they did, their eye movement data was recorded, and they were asked to give a retrospective verbal report. Each participant would watch the stimuli 2 times. And then they also completed a pre-test and post-test. So preliminary analysis of this data, which was done by Jody and Stuart and Gail. Sorry, no. So while preliminary analysis showed a significant change between the pre to post-test scores, the test scores didn't actually show much difference between each of the 3 treatment groups. And similarly, the preliminary analysis of the eye tracking data didn't suggest very much difference either. So my role in like the data analysis here over the summer was working with the verbal reports. So I transcribed and coded this data. And there were some really interesting insights. So I'm going to talk about coding a little bit first, and then I'll talk about the insights. But basically, in creating a coding scheme, it involved writing out everything the students said, and then classifying the nature of a participant's statement as either being descriptive or explanatory. So someone saying, "It looks like popcorn," about the background might have been more like a descriptive statement, whereas a student saying or trying to describe what was happening in the scene would be explanatory. Explanatory statements were then further classified into being a correct statement or a statement of a misconception. And while we aren't completely finished with analyzing this data, there were some really interesting things that I noticed while going through all of it and doing the transcription. So often, students tended to infer causality where none existed, regardless of the color treatment. So very often, you would see, and then the ligand tried to do this, or and then tried, or it's trying to, or very frequent phrasings that came up. But what was more interesting and most kind of unexpected was that students in the color transition group actually attributed that transition from full color to selective color as being a significant event in the receptor ligand process, binding process. So essentially what we as biomedical communicators or illustrators had thought to be a simple visual cue or a storytelling device had actually caused the viewer to form kind of a misunderstanding of what we were trying to explain. Is that the right direction? So what does this mean for us as communicators? So while color cues are powerful tools for guiding attention in static illustrations, their translation to animation may not be as effective. Color cues in dynamic visualization can successfully tell a viewer where to look, but the role of color cues in dynamic visualization is a bit more complex than in static illustration. While color cues are, whoa, that's in there twice. So essentially the trouble with color cues is that they struggle to indicate when to look. So if I'm showing you the same scene in the same color code at all times, there's the back button, with the red and the green, you're seeing the same red and green the whole time throughout the animation. And so that's not telling you when you need to be attending to these details. Yes. And then another kind of issue with animation and static color cues is the temporal aspect of animation. It makes the business of cueing more complex, as a viewer's kind of obedience to your cue will decrease over time. And then again, with the complicated molecular environment where everything is in motion and moving around, motion is also a pre-attentive feature, so we're likely to start attending to that too. And thus it'll hinder the long-term success of the static color cue, because there's so many things competing for the viewer's attention in this new spatial, temporal, non-static visualization. Sorry. So yeah, so ultimately, while color cues can and do guide a viewer's eye while watching an animation, successfully guiding attention doesn't strictly guarantee enhanced learning. Studies examining the effects of static cues on learning found that while static illustration-derived cues in dynamic animations were effective in guiding attention, this didn't necessarily translate to learning gains, which is kind of in line with what we saw in like our own study and data. So just sort of two takeaways for me about what I learned about color through going through all of this and the process of coding all of this data. First, when using color to guide attention, we need to be mindful as to how what we think of as simple illustrative tools might be interpreted by our audience. While our illustrative techniques are capable of clarifying complex information, they are also capable of harming the readability of our work, like that instance in that color transition where students actually took it to mean something significant when it didn't. And second, the techniques we use to create visual cues in static illustrations may not always be an appropriate way of cueing in an animation. Due to its transient nature, many aspects of an animation may compete with our viewers' attention for a color cue. That felt very short. That's all I got. And just some quick thanks to wrap up here. I did want to thank Jody for hiring me on over the summer. It was wonderful working with you. And Andrea for getting very excited about numbers and stats with me all summer, and the BMCAA for all of their work.